Our next talk will be by Daniel Hiller of Red Hat, and it will be about fixing or detecting flaky tests using AI.
Yeah, hello everyone. My name is Daniel Hiller. I'm from Red Hat, and I'm going to talk about Flakes, especially how we are trying to solve the problem for our use cases. So the quick agenda is that I'll be talking a little bit about me, about what the problem is, about what we are currently having, the CANNIER approach, and how we are going to hopefully solve it at some point. And hopefully we have time for questions. Let's see how that goes. But just a short note, I'll be around afterwards. So if you have questions, please don't hesitate to approach me and ask questions afterwards. So yeah, I'm inside the KubeVirt project as a CI maintainer. KubeVirt is virtualization for Kubernetes. So you're running virtual machines inside Kubernetes. My main concerns are our CI system, like the CI health and like flaky tests. So let's dive right in. What is a flake? So let's see how that works here. That's a failed test run of one of the lanes, which you see here, and that is a commit ID. So what you see here basically is that there is a run where one test has failed, and afterwards it has passed. That's basically a flake, because you didn't have any changes inside the code base, and that's what all this is about. So a flake is a test that without any code change will either fail or pass in successive runs. Why is this a problem? So the developers that have been interviewed by a meta survey, the survey of flaky tests, that I've been talking about earlier in like a session 2 years ago, were largely of the opinion that it is a serious problem, and also the people that encountered that were basically 15% of these were handling these cases daily. So this is fine, the obvious meme, obviously. So the problems that we have encountered basically is, because we're an open source project, we have like two views on the problem. There is, first of all, there's the individual contributor. They just care about their feedback cycles. They just want to have the feedback as fast as possible. So the problem with flaky tests is, at first you would probably say, okay, I need to rerun all the tests again to get the feedback, and I will not trust the test anymore. That are basically the problems that you are having as an individual contributor. For the project community overall, there is a slowdown of the merging of pull requests, which basically you can think about like a set of change sets that you want to get in, and like the set or the queue, which basically is like the merge queue, is basically blocked by these things or like held. There is also the problem that normally you always have like acceleration techniques, like merging multiple change sets at once, for example, and if you have one flake, this one is wasted. So this basically leads to a lot of waste on CI resources. So the goal that we want to achieve is we don't want flaky tests to enter the code base. And the only way to find out the flakiness of a test is to run it as often as you can. Otherwise, you will not know. Because this meta survey that I talked about is basically saying that there is an 88% chance with 5 runs that you can find a flaky test. But you can also have tests that might be flaky only once in 10,000 runs. So you need to run it. So what we currently have is we have like a pre-merge detection, which is basically like a technique to rerun a couple of tests that have been changed. And we are trying to rerun them in, let's see, random order and a couple of times. So basically, that's why we run them 5 times in random order. So the random order is required because you don't want to have test dependencies. You probably know. Yeah, I would explain afterwards. The problem in our use case is that our E2E tests, like we have, I think, 1,600 E2E tests or something that we're running. Most of these take around 10 seconds to 2 minutes. Since we are running 5 times and it only has an 88% chance, we run them quite a lot. So each rerun takes around like 30 minutes. And if you are having like a too big of a change set for change tests, you need to cap the amount, because at some point you can't, you have the natural limit of a test lane that must not run longer than a specific time, otherwise it would be wasted. So enter CANNIER. CANNIER is a paper from a university. Basically, I forgot, I'm sorry for that, but you need to look that up. But they found with the CANNIER approach that they were able to reduce the rerun time by 88%, and that's why this matters for us. So we looked at how to implement that. Technically, basically, this is like a predictive approach, predictive AI. It's not a large language model. Actually, what we want is we want to know whether a test is flaky or not. So we try to categorize all these by a set of features that you put into a vector and then get a prediction from the model. That's basically what you see here. You have a test case, the prediction is made, and then you get 3 labels. You get either the positive predicted label, so the test is flaky actually, the negative predicted label, it is not flaky, and the I don't know class, I would say. So like this is the class that you basically need to run then still. So the others you don't because you know, but these then you don't know, you still have to run them. So probably is a bit small, but yeah, largely this is the feature vector that is the set of features that is stemming from the CANNIER. What we can say is we can largely group those features into runtime data and static analysis data. So like I would probably highlight cyclomatic complexity, lines of code, AST depth, for example, and for example, like for runtime data, runtime and wait time, these things. But there is obviously more. So we looked at that, but the problem is there is an implementation, but it is in Python. So anyone who uses Python, you're good to go. You can use it, which is great, I think. But we're not so lucky because KubeVirt is inside the Kubernetes ecosystem. Therefore, we're using Go. So this is completely different. We don't have an implementation. So we thought at looking how to implement that. So there were also problems. Where do we store the runtime data, which I talked about earlier? You need something. How do we capture that, and where do we store it? Then also, like the data science thing. So do we have like the measures that we need for implementing that even? So again, what we came up with then was we have a couple of Go implementations that we need to do, like the model generation, prediction, feature extraction, test set extraction. The test name we would basically just modify to call for the prediction, but then we would also need to host the model basically. Like inside our cluster, that would not be that big of a problem, but you still need to do that. While I was thinking about that, had already a couple of ideas to probable optimizations that would lead from that, basically, after we have that. We're not there yet. We are only having like a rough implementation, and it's not doing everything like it should. But basically, I had further ideas for the future. So what I wanted to see is, there is data hidden in the feature vector that is basically very useful to the user who is actually like doing the contribution. So like if you're already like having the cyclomatic complexity value for a test function, you would basically say, okay, I can give that to the user and advise him probably that this is not so great and you need to improve on that. So there is data hidden that is interesting. And I would want to attach that to give the user some help on how they are working with their code. The other thing is that when you're having that data about runtimes and stuff, you can probably automate for like grouping the tests into clusters, of which you would then run probably the fastest first, and then the slower ones second, or probably parallelize them so that you get more faster feedback on the fast classes, on the fast tests. Yeah, so that's what we were looking at. Further, what we wanted to have basically would be something like that would not just be like a script that you would run, but something like that would integrate into our CI system. Our CI system is PRAO, which is basically like what nearly everyone in the Kubernetes ecosystem uses. And if we can create a PRAO external plugin that other people could use, that would be helpful for the community. That's why I was thinking, let's try to put all this into like an external PRAO plugin so that everyone can use this. I have no hard data about how many people are actually using Ginkgo, for example, because for now, we are specifically targeting the Ginkgo test environment. But I've seen like that a lot of people are using Ginkgo, like from what I've seen in the Kubernetes community, but I don't have any hard data. But still, this would just be an implementation detail. I think if you're using normal testing in Go, you wouldn't even have the problems that we have with finding which tests have been basically changed inside the Ginkgo structure, right? If the people who know Ginkgo probably know what I'm talking about. Like if you're having like several thousand lines of code file, and you're having several hundreds of tests, it's very hard to exactly rerun a single test because you normally don't find the name. But that's probably like only for 2 people in the room, like I see here. Okay, some final remarks. The CANNIER approach is, I think I said that already, like the approach itself is basically language agnostic. That's why we were thinking about re-implementing it in Go. Our implementation is, as I said, highly dependent on the Ginkgo testing framework itself, but that the adaptation would basically not just be like an implementation detail, I think. Yeah, some links I've added. I think the slides are downloadable already, so you should probably be able to find all these. There is the CANNIER paper, the original paper, the implementation of the CANNIER framework, like for Python project, this is already available. I didn't actually test it, but I believe it works because the paper exists. There is a pull request which I'm working on, which is at the moment storing the current implementation or the work in progress that I've done already on that. And yeah, as a basis probably for you to refresh about how important an issue Flakes are, you can probably also watch my FOSSEN presentation of 2024. So, I've been a bit fast probably. But yeah, we have a minute of question time.
Yeah, exactly. So I think we can sneak in one fast question. If we have an audience question, is there someone? Here, there in the back. So can you please repeat the question with the microphone? Thank you.
So you're completely rebuilding the logic which is available in Python in Go then, so that you can implement?
Yes. So the thing is, Python doesn't have probably the problems that we have. So, like I said, Ginkgo is like a framework that helps you with a dynamic structured language, basically to describe structures of testing. So tests that relate to each other are all below some specific node, for example. And it was not very hard to somehow like rebuild the code that CANNIER is. Actually, the more problems we did have with finding actually the tests that have changed. So the majority of code is rather about things that are specific for us.
Thank you very much, Daniel. Very interesting talk. And see you again in 5 minutes for the next one.
Thank you. Thank you.